So in this video, we are going to pick up probability. And you guys haven't talked about probability in a long time. Probably not since Algebra 1, but the probability that you guys have talked about was usually like spinning a spinner or picking a marble out of a bag or something like that. And so we're going to kind of ease in with a topic that you guys learned about that, and then we're going to step it up a notch. Okay, and this video specifically is going to be about what we call permutations. Okay, and permutations and the next topic, which is going to be combinations, but these both build off of something that you learned when you were doing those spinner and those marble problems, and that is the counting principle. So the counting principle is like the main, P-R-I-N-C-I-P-L-E. The counting principle is like the main stat idea that goes behind permutations and combinations. And the counting principle basically says if we have one event that can happen n ways, so n number of ways, and the second event, S-E-C-O-N-D, and then a second event that can happen we'll say m number of ways, then both of the events happen together is going to happen n times n ways. So then both events okay, and you guys have actually done this before, so think back to those like outfit problems or those making an ice cream cone problems where we'd say, okay, well, let's say that you have we have chocolate ice cream and we have vanilla ice cream. And we also have, you can put on sprinkles or whipped cream or, I don't know, peanuts. And then you can put on chocolate syrup or you can put on strawberry syrup. Okay, and we would ask you how many different types of sundaes could they make. And sometimes we would actually have you draw out a tree diagram, okay, where you would say, okay, well, I could have, I would pick and I would have chocolate or vanilla ice cream. And then we would say, well, I could have sprinkles, whipped cream, or peanuts. Same thing if I picked vanilla. And then from that, I could pick chocolate or strawberry, right? And these things got super complicated. Whew, running out of room. And by the end, we would say, okay, I've got 2, 4, 6, 8, 10, 12. There were 12 possible sundaes that you could have made. Okay, or later on, hopefully somebody taught you that you'd say, well, there are 2 kinds of ice cream, and there are 3 kinds of toppings, and there are 2 kinds of syrups. So we're just going to do 2 times 3 times 2, and that's going to give you your answer. Okay, that's going to give you the different number of types of sundaes in this case without having to do that messy diagram. And that's what we call the counting principle, this 2 times 3 times 2. That's the counting principle. Okay, but like I said, we're going to take that counting principle and we are going to step it up a notch. Okay, and the first thing, permutations. permutations, these are arrangements in a specific order. Okay, and the thing that makes permutations tricky is that they have to happen in a specific order. So instead of saying, you know, out of everybody in class, I'm going to pick 3 people to help me. Okay, well, it doesn't matter who I pick or when I pick you. I'm just picking 3 people. But if it's a permutation, I've got a whole class, and I'm going to pick a first place, second place, and a third place of who did best. Well, then obviously the order in which I pick you matters because that order determines which place you got. So a permutation is an arrangement in which it has to happen in a specific order, or order actually matters. Okay, and in general, if we have n objects and we pick r of them, okay, so n and r are just numbers, then the notation for this is a little n, a big P for permutation, and a little r. Okay, so the little n is our total number of things, our total number of objects, and then r is how many we pick. Okay, and this actually has a formula. Okay, we say NPR, not the radio station, but NPR is equal to n factorial all over n minus r factorial. Okay, and if we need to come over here to Happy Math Land to remember factorials, although I think we remember this, because I think we talked about it a couple days ago. If I give you something like 3 factorial, factorial looks like an exclamation point, that means I'm going to do 3 times all of the counting numbers below it. So 3 times 2 times 1. If I do 4 factorial, that's going to be 4 times 3 times 2 times 1. 2 factorial would be 2 times 1. Okay, the big one that everybody likes to forget is 0 factorial. Okay, 0 factorial is equal to 1. Just like anything to the 0 power is 1, 0 factorial is 1. Okay, so you need to remember that 0 factorial is 1. You need to actually remember what factorials are, and then this is pretty important. Okay, so let's do an example. First, let's see how I'm doing on time. Oh, okay. And I'll keep that up there. Okay, so let's do an example. Let's assume I have 5 coins in my pocket. Okay, let's say I have a penny, a nickel, a dime, a quarter, and then one of those weird half pieces with Kennedy on them. Okay, for my first question, I want to find out all of the different ways that I could pull 2 coins out of my pocket. So number of ways to pull 2 coins out. Now in this case, order does matter, okay? Because if I go in my pocket and I pull out a penny, by taking that penny out, that changes the options that are going to be there from when I put my hand in the second time. Okay, taking out the penny changes the name of the game. Okay, so that is why in this case order matters. So if I have 5 total things, when I write this in this format, here's going to be my 5, because n is 5, it's my total, and then it's a permutation, so I put the p, and then I want 2, so my r is 2. So this is going to be np2, and that is going to be equal to 5 factorial all over 5 minus 2 factorial. Okay, so, and then I'm going to write this out. 5 factorial is 5 times 4 times 3 times 2 times 1. And 5 minus 2 factorial, well, that's really 3 factorial. So this is going to be 3 times 2 times 1. Okay, and bam, 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 those cancel. So I'm left with 5 times 4, which is 20. So that means that there are 20 different ways that I could pull 2 coins out of my pocket if I have these 5 coins in there. Okay, 20 different ways. Doing this is a lot easier than writing out 20 different possibilities. Okay, let's do another example. Numero dos. How about the number of ways to pull 3 coins out? Okay, we're doing this in NPR format. My n is the same. I've got 5 coins. It's a permutation because order matters, and I'm pulling out 3 of them. So this is going to be 5 factorial all over 5 minus 3 factorial. 5 times 4 times 3 times 2 times 1. And this 5 minus 3 is really 2, so this is 2 factorial. 2 factorial is just 2 times 1. Again, cancel. And I'm left with 5 times 4 times 3, which is 60. So there are 60 different ways to pull out 3 coins. This is what's going to happen on the Regents exam. They are going to give you something, and it's going to be a lame multiple choice question, where if you write out all 60 possibilities, it is going to take you forever and a day. Okay? Know this. Okay? And my trick, personally, is, this is how I kind of think of it. Whatever my R is, so like in this case it was a 3, that tells me that I want the first 3 things of 5 factorial. Because look, after I canceled, I was left with the first 3 things. Or when I go back to this first example, it was 5p2. Okay, when after I canceled everything, I was left with the first 2 of 5 factorial. So that's how I kind of check mine. All right, let's do, I think I have one more example. Yep, one more. Okay, what about number of ways to pick out all 5? To pull 5 coins out. Okay, remember we're doing NPR. So I'm doing 5p5, which is going to be 5 factorial all over 5 minus 5 factorial, which is 5 times 4 times 3 times 2 times 1 all over. Now 0 factorial isn't 0, it's 1. Okay, and then when I do 5 times 4 times 3 times 2 times 1, you get 120. So there are 120 different ways to pull out all 5 coins from my pocket. Okay, and remember, as a nice little check, if my R is 5, that's how many parts of 5 factorial I want to use. 1, 2, 3, 4, 5. That's how I get my 120, okay? Yeah, you could say that the 1's canceled, but 1 is just 1, so you can throw it back in there. Okay, and in general, I'll write this in a different color. If we ever have n things and we want to pick all n of them out, this always happens up here. We end up just doing n factorial. Okay, and before I go, okay, we're done with this example, but what I would like to do is I would like to show you this in your calculator, because actually you don't need to memorize all of this stuff in your calculator. Let me just open up my calculator program and we'll get this going. Loading. Okay, there we go. That's what was up from the last time. And if we look, all right, I'm going to do this example right here just to show you guys how to do this in your calculator. I'll do, whoops, didn't want to pull that, want my highlighter. I will do, what's going on? I'll do this one. I will do 5p3 in my calculator just to show you. So if I look, let's get out of that. Second, quit. Okay, so if I'm in my normal calculator, what I'm going to do is I'm going to hit math. And if you go over to PRB, that stands for probability. All right, and if you look, it's got some really nice stuff. It's got NPR, which is our permutations, which we just talked about. It's got this NCR, which is for combinations. We're going to talk about that soon. And then choice 4 is factorial. So if you don't want to write it all out, you can be lazy and put it in your calculator. Okay, but let's say I want to do this 5p3 in my calculator. Okay, you can't go right in and hit this. Okay, what you need to do is before you do that, you need to hit your 5, your n, then go to math, go over to probability, and then hit your 3. Okay, so you need to put in your n before you go over to the probability section. Hit enter, there you go, 60. That is exactly what we got. Okay, so that is how you do this in your calculator, and I am donezo.